See, all these videos I have recorded. I will give you a link where I've added your email, so you can access those video later also. So I will give you a link. Okay. Now coming back to NGR failure. Okay. So what we see NGR, when you say failure of any electrical equipment, it can be either an open circuit or it can be a short circuit. Now, in a NGR, when we say open circuit, it happens mainly when the see in a NGR, when does this one happen? And see when corrosion of that. See what is NGR made of? NGR is made of a resistor, right? That resistor is made of a metal sheet, right? Now, when that metal sheet undergoes corrosion, what happens? It will break. There is an open circuit. That is one problem. The other problem is when there is a short circuit. When I say short circuit, see when this porcelain insulator, when this get carbonized or something, we can say it's a short. It is not exactly a short circuit. See, the resistance will only reduce by some small value. So open circuit is a big problem for a NGR than a short circuit, right? Then see there is a relay also here, and the relay will try to sense the failure of the NGR. Okay, I will explain about that also. And as I told you, short circuit is very rare, and because here even you see, first thing is this is between neutral to ground, so short circuit is very rare here. And one more thing is we have designed the vendor has designed the NGR to tolerate certain temperature. It may so happen that the temperature rise may go beyond the design, right? The temperature may rise beyond the design when ingress protection, cooling, all those is not properly designed, or the dust has accumulated and there is no cooling at all. So then the NGR temperature may increase and it may then also it may fail. How it will fail? See, when temperature increases, the joint maybe welded or bolted, whatever it is, the joints will fail. And if the joint fail, it is, and it becomes an open circuit. That time we can say NGR has failed. And one more thing, vibration, manufacturing defect, lightning, storm, bad weather, these can also lead to failure. And failure of the weld also is very important. If the welding joint fail, and then also NGR will fail. Okay. And as I told previously, NGR is basically made of a number of series path, right? All these are series path, right? So how many paths are there here? One, two, three, four, five, six, seven, eight, nine, 10. Some 17 or 18 resistors are connected in series. Okay. Similarly, if you go here also you can see one, two, three, four, five, six, 7 resistors are connected in series, and each of them are then each of the 7 is in parallel. So you have 7 series and 2 parallel paths. So NGR is made of a number of series and parallel connections. Okay. So when a NGR fail, the resistance will change by some value. Okay. If it become an open circuit, resistance will become infinite, current will become zero. If any one particular resistor fail, then there will be a small change in the resistance. Okay. Now coming to monitoring of the NGR. See, when a NGR fails And if I don't know that the NGR has failed, then what is the problem? What is the problem if NGR fails? Can any one of you tell me?
It's an open circuit, sir. It means if you have a fault, then you will. It becomes like an ungrounded system. So you'll have a high voltage, low current, very high voltage. You will get on your system.
Okay, you are perfectly correct. When NGR fail, it will become a very high resistance or infinite resistance, and then basically it will become an ungrounded system. You are correct. And ungrounded system, the main problem is high voltage. There will be a transient voltage or a higher voltage. So you are correct. That is one big problem. So what we have to do, we have to monitor whether NGR is fine or not. How do we monitor? We will use a relay. See, this one is a relay. This rectangle box. What is there in this rectangle box? This is a relay. Okay. Now this is my source. This is my neutral, and I have grounded the neutral through a NGR. Okay. This is the NGR. Now this is the NGR. I have connected it to the neutral. Okay. Now to monitor that, I am using a relay, this relay, and there will be a current transformer here. Okay. And I have one external. I have one more small resistor which is provided as a part of this relay itself. Now, what does this relay do basically? Okay, it basically injects a current through the resistor. So here there is a current source. That current will go via this resistor to the neutral and then come back return via the NGR. Then via your grounding, it will come back to the relay. Okay. So basically, I'm injecting a small current, and this current will not cause any heating of your NGR because it is very small, very small current. Now there is a CT. This CT will measure the current, and there is a voltmeter which will measure the voltage across this. So I know the current, I know the voltage. I will compute the resistance. So continuously, so this is not a hi-fi relay, it is simple relay, but it is very important relay. It continuously keeps monitoring the NGR. If the resistance become very high or very low, then this relay will give an alarm because this relay can't give any trip or you can't trip anything, right? Normally, what a relay does, it will trip a breaker. But here there is no question of tripping any breaker. It will give an alarm. And if you are having two transformers, see, normally in a plant, what is the configuration we have in a plant normally? Normally in any plant, we are having like these two transformers, right? For redundancy. So let's say this is a 11 bar 6.6 kV transformer, which is 2.5 MVA. I have one more 11 bar 6.6 kV transformer, 2.5 MVA. This is delta, this is star grounded. And here I am using a NGR. Okay, there will be a disconnector here. So this is the NGR. Fine. So this is my NGR. Now let's say this is feeding a number of motor. So normally this is how all your plant configuration is, correct? Okay, am I correct? This is
Yes,
how
sir.
any big plant. This is the configuration. So now let us say this NGR got failed. Let's say this particular NGR is failed. Now if this NGR has failed, then what do I do? So I have to open this breaker, okay, and this entire part will I will shut down the power, and then I can check this NGR. Okay, suppose my plant is something like this. See, if my plant had only one part, if this my plant is of this configuration, then it would have been difficult to shut down the plant. But now my plant is having redundancy, so I can shut down the right side transformer. I can transfer all the load to the left side. Okay, I can open this breaker first and then close this breaker, right? So it will be something like this. Okay, I can open this breaker, I can close this breaker, and then I can open the upstream breaker. I can open the upstream breaker here, and then I can check the NGR. So that is how we do. Okay. Are you able to see the video? Are you able to see my screen? Yeah, able to see the screen?
Yes, sir.
Yes, sir.
Yes.
Okay, I think in between there was some.
Your voice was not coming.
Is there any problem hearing?
Now it is
No, it's
okay.
clear now.
You can hear now?
Yes.
Okay. Are you able to see this relay?
Yes.
Yes.
Okay, fine. So this relay, basically what it does is this is the relay actually which will sense the this one. I will share some pictures of this relay also. Okay, I have some pictures of this relay. I will share that with you. See, this relay actually is not required compulsorily. Okay,
Mm.
but in case of in case of actually as per some standard, this relay is required. Okay, I will. Okay, now I will show you that particular relay. Let me show you that particular relay. Common. Actually, this is a arc suppression coil. Yesterday I was talking about the other type of this one. No?
Hmm.
I was talking about reactance grounding. So this is that one. This is used in a distribution system.
Hmm.
And actually, this is that NGR with NGT. I will not go to it. This is one more type of grounding where we use this one. What is it? This is instead of a resistor, here you are using a tuned reactor. Okay, this is a special type of grounding.
Hmm.
Mm, see, these are some of the NGR with NGT. Okay, this one you can see some are having very high ingress protection also. So this is all NGR with NGT. Top what you are seeing. See, you are having the resistor here,
Hmm.
and bottom you are having the transformer. Okay. And yesterday someone of you asked regarding the capacitance. No, you were asking something on capacitance.
Hmm.
See, actually, when you have a generator or any source, this capacitance here represents all the capacitance, cable or generator, everything. And actually, if this resistance, see the resistance value. If it see the resistance value keeps on increasing, fault current will keep on reducing, right? And if the resistance value become very high or infinite, fault current will become zero. So when fault current ideally will not be zero. Why I will tell you, when the fault takes place, instead of the fault current going back through the neutral grounding resistor, it will return back to the system via this capacitance. Okay. And when fault current flows back via the system capacitance, there will be a buildup of voltage. So that is why the resistance value should not be should be such that the entire value should be less than this capacitive reactance. Okay. But see, when you do the sizing of the trans generator,
Hmm.
big power plant generator, that time we will check this. Okay. Whereas in case of this NGR, we need not check because there actually the resistance value will be very less. Not very less, sorry, very high. Here the resistance value is not so high as the power plant. Okay.
Hmm.
Okay, now see this is the NGR with NGT. This is the hybrid system I was talking about. Some people use this also. They will use a low resistance neutral grounding normally, and when a fault takes place, they will switch over to high resistance neutral grounding. So hybrid system I have not come across practically. Okay. Now, are you able to see this? Okay, I have a question to one each of you. Mr. Armugam,
Yes, sir.
this one, two, three, four, five, six. So you are having so many plates here. So you are able to see here, right?
Yes.
What are these plates?
Resistor. Individual resistance.
Okay. So these are basically resistor, right? So it's
Yes.
a combination of resistors in series and parallel, right?
Yes.
Hmm.
Yeah. And you can see here, you make a observation here. This is all made of steel, okay? But what type of steel exactly we don't know. The make this one is by a company called Pyrotech Bangalore.
I wrote it.
Can any one of you tell what is this?
It's
Ground fault relay.
what fault relay.
One by one, Mr. Ram, what is this?
It's a relay, sir, which senses the ground fault.
Okay, you are telling ground fault. Okay, Mr. Pinaki Sharma, what is this?
Ground fault relay only, sir.
Pardon?
Ground fault relay.
Okay, Mr. Ram Verma, what is this?
No, sir, I am not aware about it.
Okay, see, this the main objective of this one is actually monitoring of the neutral grounding. That time I showed you one this one, no?
Relay setup. Okay.
I showed you once the last slide. I showed you one diagram
Hmm.
where I showed you one relay which will inject a current. Correct?
Yes.
Did I not show you
Yes.
this one? This is that particular relay. This is basically this relay is used to monitor the resistor. Okay, so see, whenever the resistor is faulty, it will self resistor fault. Okay, this is a relay by Little Fuse, a very good relay. Normally, NGR monitoring is not mandatory. Okay, whereas in case of mine project, it is required. In other projects, they don't put. But if you put this relay, it is good. Okay. And ground fault, most of you told ground fault. Yes, you can determine a ground fault. How? Whenever there is a current flowing through the resistor, it means there is a fault, right? Only if there's a fault, current will flow. So relay can also monitor a ground fault, but the primary objective of this relay is to monitor the healthiness of your HGM. Okay. So
Okay.
here this one relay you have come across. This one also one more NGR with NGP. See this one
Hmm.
here. From here we are getting, then it is going like this, then it goes to the next resistor here, from there it goes here, from there here, finally here. Okay, so now this is one more bushing. So basically you have, this is one, so this is the one where you are connecting the to the neutral of the transformer. That is why here the voltage level is high. So you see the difference, bush, this one, this insulator and the insulator here. Both are different because here the full voltage line to neutral voltage will be there here, right? Here, are you able to observe this?
Yes.
Here voltage is less. That's why pushing here is different and here is different.
And we can also have neutral CTs here for protection, right, sir?
You are correct. See here, two neutral cities are located here.
Yeah.
From this neutral city, I can put it to my relay. Okay, and that can be 51N also. Okay,
Yes.
see, some people will use the word NGR, some people will use the word NER. NGR is neutral grounding resistor, NER is neutral earthing resistor, and both are same. Okay, So this was that particular relay, the fuse relay which we saw, SE330, right?
Yeah.
This is that relay. Okay. Now here, see here I'm using a NGR
Hmm.
in a plant outdoor.
Hmm.
So this one, no? This is the NGR here. I'm locating it outdoor.
Hmm.
So these are the bushing to be connected here. Yesterday you were asking, no, why current does not flow in the neutral.
Hmm.
See, actually, when you have two source and both the source, see if you have two generator, only then the circulating current problem is there, and only then the third harmonic current will flow. And the reason is because the path is getting completed through these two earthing. Mr. Pranaki Sharma, you asked this doubt, no, yesterday?
Yes, sir.
Yeah. Okay. See, you have a number of plates. Huh? The plate is basically steel plate. Now here, insulation can fail between these two. And when it fails, as I told, resistance will only reduce by small value. Okay.
Hmm.
And this is one more type. This is not a NGR. It is not basically this is a tuned reactor. And this is used for distribution system grounding. See, actually, in some nowadays, what they are doing, the new concept, not new concept, it is an old concept only, but they are implementing it in a different way. If I have my 11 kV system, 11 kV, most of the country is solidly grounded, right? But
Hmm.
the one more method is I'm going to earth my 11 kV system neutral via a tuned reactor in such
Hmm.
a way that the current, see in NGR current is 200 amps. NGR plus NGR, the neutral current is 2, 3 or 4 amps. Whereas when you use this one, no, tuned reactor, the current will be like point few amps. It will be very, very low. This so this is one more concept that they are using for distribution system grounding. And the advantage of this system is it will not lead to lower voltage, and at the same time there's a lot of safety in the system. And when a person touches, he does not get a shock.
Hmm.
Okay. Okay. Now see this particular slider. Can you tell me what is this, Mr. Armugam?
Yes, sir.
Can you tell me what is this slide?
This is the impedance diagram of the SLD.
Okay. Mr. Pranaki Sharma, what is this?
What Arun sir, it's the equivalent impedance diagram, including equivalent impedance diagram of the schematic.
Positive, negative, and zero sequence.
Yes.
Yeah.
Mr. Ram Verma, you know about positive, negative, zero sequence?
No, no, sir.
Yeah, most of us actually are not aware about this because this was a concept either it has come in the colleges, and at that time we are not aware what is the importance of this. So I will briefly explain about this, sir. This is basically, see this one what you are seeing here, no? A generator connected to your bus, and via a cable it is okay, connected here. Now this one is nothing but a single line diagram, okay? And this one is the positive sequence network of it. Now, do you remember sequence components?
Yes, sir.
Okay.
Yes, sir.
So you go through this book, Power System Analysis by Stevenson.
What is the book, sir?
Power System Analysis by Stevenson.
Stevenson.
There you have a dedicated chapter on sequence symmetrical component. See,
Okay.
because if you want to determine the fault current, you have to actually first find out the positive, negative, and zero sequence network. Any big network, you have to, from a single line diagram, you have to determine positive, negative, and zero sequence. Okay. After finding out the positive, negative, and zero sequence, to find the single line to ground fault current, what you have to do is, see, this is the positive sequence network. Okay, you have to connect all three network in series. Okay. So positive sequence network will have the voltage source. Negative sequence network is similar to positive, it will not have the voltage source. Zero sequence network also will not have voltage source. And in zero sequence network, if you have a star delta transformer, wherever there is delta, there will be a open circuit. So once you connect all three network in series, okay, and you then your resistance, no, your NGR resistor. See, this is the NGR resistor also will come here. It has to come here actually. Not here, sorry, it will come here. Because see, normal operation, when power is flowing, will current flow through the NGR?
No.
Normally, when power is flowing, current will not flow through NGR. So in positive sequence network, NGR is not coming. Okay. NGR will come only in the zero sequence network. Okay.
Sir, now suppose if you are designing a system, this zero sequence impedance,
Yeah.
it will not be available in the nameplate, right? The nameplate, whatever is available is positive sequence. Is that correct?
The nameplate, whatever is available, is only positive sequence. Yes, and negative and positive sequence are equal.
Positive and negative are equal, but about zero, sir, zero sequence.
See, actually, if you get the test data from the vendor,
Okay.
you will get all the data.
Uh,
So that is not a problem. You will get the data from the vendor.
okay.
So you substitute that data. Okay.
Okay.
And you see one more thing. Here the resistance is 3 times Rn because all three current will flow in phase. That is why neutral resistance will be shown here as 3 times Rn. And this is the capacitance Xc. The value of this should always be less than Xc to prevent buildup of voltage. Now RF is the fault resistor. Suppose there is a fault here, that fault resistor. So using this particular network, see if we log out now, please log in again. Okay, using this particular network, you can determine the single line to ground fault current. Okay, please note line to line fault, three phase, you cannot determine from this. Okay, forget the network is different. This is only network for line to ground fault current. Okay, so positive sequence network. See this particular XD double dash transformer cable, all this impedance you will get from the data sheet of the equipment. Get the from the data sheet you get it, and this one more thing, you all know about per unit method, right?
Yes, sir.
Any one of you don't know per unit method? The per unit method, actually all this calculation, if you are using sequence network, then we do the calculation using per unit method. Okay. So do you, I'm only giving a brief on this thing. Okay. So using this method, because this is a deep subject, it's related to fault current calculation. That's why I'm not covering sequence components more in depth, because sequence component itself is very in depth. Actually, any big network, no, when you do the sequence component, see, suppose if you have a network like this, zero sequence network will be like this. The reason is whenever you have a star delta transformer, no, you will have an open circuit like this. So in a sequence network, you have to make positive sequence, zero sequence, and negative sequence network separately and connect all three in series to find the single line to ground fault current. Okay. So okay. See now here, see one more example here. I'm having a NGR here. If some person touches here, the fault current will flow via, and then there is an earth return path. See, yesterday one of you asked me this doubt. What is the effect of earth when the fault current flows back? See, if there's a fault here, no, most of the fault is going back. See, some current is going via the cable armor, and also if you see this particular equipment will be connected to the earth grid. So majority of the current will go via that path. Only a small amount of fault current will flow via the ground. Okay. So there in the previous slide, no, see, I was telling you about this one, no. See, we have found the positive impedance, negative impedance, and then we have added the NGR resistance. See here, three times. This is the single line. This is the single line to ground fault sequence network. Okay. If you use this network using this method also, you can determine the fault current. Okay. Now, uh, so the main standards which we have used, see after we log out, please log in again and we'll do a quick revision. Okay. The main standards which has been used to develop this particular this one.